Okay, let us start. A pleasant afternoon, everyone. We are going to discuss this afternoon about chapter 3, which is about periodic trends of elements. This is just a continuation of what we have discussed in atoms and periodic table. Yeah, but in that chapter, what we had done is we just let you introduce. We introduce only the basic of what is periodic table. What is its column? No? What is its period, like that? No? But the deeper sense, at the same time, especially the characteristic and the properties of elements in each of the consisting periodic properties is not yet discussed. This is what we are going to do this afternoon. So let's move on. So these are the following objectives of this lesson. The first one is we are going to describe the brief history of periodic trends, when it started and when could we consider it as a modern periodic table. The second one is we are going to describe what is modern periodic table in terms of its properties and in terms of its characteristic. What makes them different from the old periodic table? The third is we are going to relate periodic behavior. What do you mean by behavior? What particular behavior? Its properties, its properties, especially physical properties, chemical properties, with its atomic number. What is the importance of atomic number? Later on, you will find it out. And what is effective nuclear charge? The fourth objective is we are going to predict its properties. Its properties through, through the atomic radii. What do you mean by atomic radii? It's the radius of the atom. Then ionic radii, atomic and ionic radii is different because if you talk about ionic, it has something to do with atoms which has charge. It could either be a positive charge or a negative charge. Then we will also describe what is ionization energy, what is electron affinity, and affinity in terms of its characteristic to these trends of the elements in the periodic table. And the last one, we will correlate that into electronic configuration. So these are the things that we are going to describe in this chapter. So the first thing that we should know is periodic table was discovered by Dmitry Mendeleev. So he is the first one to arrange it in periodic table. What do you mean periodic table? Meaning increasing. Increasing, that is why it's called periodic. But the problem with Dmitry Mendeleev, his arrangement of the atoms is being based on atomic mass. Diba? Kabalo na mo sa atomic mass. Atomic mass katong nasa ubos, no? The atomic number is different from atomic mass. Atomic mass katong nasa ubos. The other term for atomic mass is the molecular weight or the atomic weight, no? So that is it. That is how Mendeleev arranged the elements according to its atomic mass. Now, he noticed that they have similar and chemical properties, but some elements were out of order. Mo itong tanaw niya, ang uban coincide, ang uban wala. Na? Why? Ngano kaha? So this is the old periodic table that was being discovered by Mendeleev. That one, kani siya, wala siya. So his basis is increasing. He arranged it with the increasing atomic number. Okay. Later on, it was Henry Moseley. Henry Moseley now arranged the element by atomic number. Unsa to ka Mendeleev, he arranged it by means of atomic mass. And this is now the so-called modern table. In which way we're in during the time that Mendeleev had arranged it, he found out there are some discrepancies. May mga kasayop-sayop. Nga naman, because it is atomic mass. But when Henry Moseley arrange it by means of increasing atomic number, okay na siya. No? So he called this as periodic law. What is periodic law? This is the properties of the elements are periodic function of their atomic number. Meaning, na, the properties of the elements coincides with its atomic number. Meaning there is a pattern. What is the sequence? It's increasing. That is according to Mosley. Okay. So this is what they have discovered. Kani ang unang na discover ni Demetri at the same time Lothar Meyer. Okay? So these are the first elements which is being in place in the periodic table. Gamay pa ni siya, no? Unlike today. So as you can see here, these elements are being classified into, if you look into the color here, this signifies what year or what time was it being discovered. For instance, the ancient times, that is color violet, that this one, kani, mga ancient times ni, meaning copper, no, silver, gold, this one here, are being discovered during ancient times. Dugay na din ni sila nabalaan. Then, during Middle Ages, that is 17th century, this color, what color is that? It signifies this kani, the zinc, the as, somewhat like that. Then, during 1735 to 1843, there is that color of the light blue. Actually, if you look into it, mas daghan siya. Na? So, at this period, daghan ang na-discover ng mga element. Then this brown, that brown then, no? Example, helium, gallium, like that. This is during 1843 to 1856. Then this color here, no, is during 1894 to 1918. What is this? Kaning mga kani. Mostly the noble gas, so on and so forth. Then, this one, kani, is 1965 to the present. Okay, wala na nadungag karon. It's only 180. So that is how it is being done. At the same time, this is the time frame wherein these elements had been discovered. So it was the Otto de Mendeleev, which is being patterned by Mosley. No? So they come up with Dmitry Mendeleev and Lothar Meyer with what we have now. That is the periodic table that what we have. Okay. So the development of this periodic table, no? For instance, 1871, no? Mendeleev predicted this germanium, which is so-called eka-silicon, no? So, which is in between, no? The atomic weight of zinc and arsenic, and that is now the silicon, like that. So, looking into the classification of elements, they could either be metals, metalloids, and non-metals. Later on, we will discuss its properties. If you look into the periodic table, no, the first row there, no, not row, first group or first column here is classified as the alkali metals. No? We already know that these elements are classified into three, that is metals, metalloids, and non-metals. Where can we find it in the periodic table? So this is the alkali metals. This is group 1, 1A. This is group 2A, alkaline earth metal. Then this part here is the transition metal. This part sa ubos is the inner transition metal. This zigzag here, no? This zigzag line here is the demarcation between the metals and the non-metals. So kaning nag-zigzagan hiya, they are known as the metalloids. Metalloids has a characteristic of either a metal and a non-metal. It's easily to memorize this because there are only 6. That's the boron, silicon, actinium, that one, the antimony, and germanium. Okay, so this side here, the left side are all metals. Kani left side na siya. Then the zigzag parts here are the metalloids, and the right side here are the non-metals. Under non-metals, we have the group 7, that is halogen. Then we have the group 8, which are the noble gas. Okay, we will describe each of this group one at a time in the succeeding slide. So, take a look. Padulong gani nganha paana mo ana is known as, kung row gani, it is known as the period. Ang tawag ana sa to, it's periods, na horizontal rows. They are horizontal rows like that, na the members have the same number of principal energy level. Kung sa may distinguishing niya, meaning kaninga na that is 1s na tanan. Tas ngani na po dapit is 2p na siya. Kaninga ni mga s, kaninga ni p. Tas kaninga ni is d and f. Ana na siya. Adi more gani dapit ang d then f ninga na siya. So mao na distinguishing characteristic of the period. Kung sa to, it's they have the same principal energy level. Kaninga part nga niya is S, kaninga part nga ni is P, this part here is D orbital, this part here is kani F orbital. Then for the group paana, that ana, that is the vertical column. The name of that is they are group or families. Ang pa row gani is period. Ang paana is group or families. So members have the same number of valence electrons. What does it mean by that? Meaning if it belongs to group 1A, meaning the outermost shell of your element has 1 electrons outside of its outermost shell. Kana tanan niya kanang group 1A. Group 2A, the outermost shell, that is valence electron, is 2. Then this halogen, they have 7. Okay. Noble gas has 8. Ano tawag ana? Ang difference sa period, ang period, they have the same principal energy level, while for the group, they have the same valence electron. Okay? That's the distinguishing properties of that. Okay. Then, let's move on. Let us now differ the characteristic of metals, metalloids, and non-metals. So, under metals, it has luster. Luster meaning shiny. It's ductile. It's malleable, meaning turn into sheet. They are good conductor of heat and electricity. That is why most of our electrical wirings are made. These are made of metals, and they have a high melting and boiling point. For metalloids, metalloids have the characteristic of either a metal and a non-metal. Nas tunga-tunga siya. Okay. So, they are semi-metals. Semi meaning dili gid siya metal, pero murag metal. Okay. Then it has the touch aside of the staircase. Touch aside kato bitong ana katong zigzag, mao na sila ang metalloids. And has both properties of metals and non-metals in between. For instance, the boron, the silicon, this one. Okay. Silicon is the one that is being used in surgery, not surgery nga, it is plastic surgery for the face and for enhancement, boobs enhancement. Tapos gusto mo og mudako inyong sampot, pwede po na siya butangan og silicon. Gusto mo mutaas og ilok, pwede siya butangan og silicon. So that is, silicon is a metalloid. So, why problema ang inyong ilong butang silicon aron mo taas? Okay nga naman. Dili man na pag ana news detector, di man na may titit nga naman. Di man siya metal, di po siya non-metal. In between siya. So, it's easy to memorize these metalloids. There are only 6. Memorize this one. For non-metals, these are the characteristics. They are dull. Oh, wait lang. Dull. Wildlife. Dull. No? Meaning they are not the same with the metal which has a shiny color. They are brittle solids, meaning dali na sila mo mabalik. Na? They are poor conductors of heat and electricity. That is why in the ladle, what si as ladle, kana ba sa ana sa pagkaon? Sa kanang binungag. Okay. Kung it's pure metal alone, what will happen if you just leave it for a moment? What will happen? Paghawid mo sa handle sa ibabaw is init kayo, no? Why? Because metals are good conductors of heat and electricity. So what happened is, in most cases, they had to wrap the upper portion, the handle, with a non-metal, and that is a rubber. Aron dili siya. Paghawid ni mo, dili init. Kaya naman, because rubber are non-metals, are made of non-metals. So they have low melting point and low boiling point. Let us describe each of the group. For instance, group 1, these are group 1A. What is the name of that? They are alkali metal. What is the distinguishing properties of this? It has a valence electron of 1, meaning its outermost shell na ay positive 1. Positive 1, ha? Okay. Then, this is the most active metal. Kani ang most active metal. Meaning, kung yung active, dali ra siya mo react. Ha? Not found in nature by themselves, form stable compounds. So, it's easy for this to combine with other elements to form into a stable compound. And they can be obtained by electrolysis of salt or by means of salt. For instance, sodium. When sodium combines with chlorine, you will form a salt, which is sodium chloride, and it's stable. That is group 1A. Group 2A are known as the alkaline earth metal. Kani. Group 2A ni siya. It starts with beryllium, magnesium, calcium, strontium, barium, radium. No? Ang outermost shell niya, how many electrons? It has 2. This is the second most active metal. No? Some are not found in nature by themselves. Okay? Then the group 17 or the group 7B, they are known as the halogens. Kanina gyud sila pong upat. Chlorine, chlorine, bromine, iodine, kani dili siya mo react. Dili ni siya mo react. Only these 4 no, are classified as halogen who are reactives. Most common ion, no, meaning this could easily combines with the group 1. Nga naman, pito ba ka electrons ni plus 1, 8. Can you still remember? It will only be stable unless it has its octet configuration, meaning 8 electrons. No? So, kinahanglan na siya 1. So, what happened in the group 1? No? It will donate 1 electron here to make it 8. No? So, ang iyang kauban ani Fermi counterpart nga dali siya mo react is the group 1A. Okay, 7 plus 1, 8. No? So, they have all state of matter at room temperature. At room temperature, naani sila nga mga state. For instance, our chlorine, di ba? Naay chlorine nga powder, naay chlorine nga liquid. The one that is being used in water district for disinfecting, na, it is being added on is a chlorine gas. So kaning fluorine, bromine, iodine, naani siya sa tanong state of matter. That is, it could either be solid, liquid, and gas. Our most reactive non-metal. Kung naay most reactive metal, which is group 1A, this is also the most reactive non-metal. That is halogen. The next one is the noble gas. From the word inert. Noble, what makes it noble? Meaning it's stable. No? Why? Because the outermost shell here has 8 electrons, meaning it doesn't need any element to make it stable because it's stable in itself, except helium. Helium has 2. Pero stable na siya kay the first energy, main energy level has 2 electrons, followed by 8, 8. No? So inert gas, non-reactive. What makes it non-reactive? Because they are stable. 8 electrons naman. So have most stable electron configuration of 8 electrons in the valence shell. Krypton, xenon, panagsa mo reacts sa fluorine. Panagsarag yan. So, that is group A. We have the transition elements. Katong nasa ubos. Kaninga ni adapted nga side. Pag humasa 2A, transition na siya. So, these transition elements. Some of it has many positive oxidation number. What do you mean by many positive oxidation number? For instance, fluorine has 2 oxidation number. No? It could be Fe2 plus and Fe3 plus. Okay, that is cobalt also has 2, no? CO plus 1 and CO plus 2. Nickel same, copper same. So this mo na ginatawag og many positive oxidation number. It could have 2 or more, no? Kaning uban, no? Then the valence electron are various energy levels. So they can lose electrons from more than one energy level because they have many positive oxidation number. So when this form as a solution, for instance, fluorine adds up with chlorine, you will have a yellow color. Colorful ni mga transition elements, basta mo react. When copper combines with other element, for instance, sulfate, copper sulfate, you will have a blue. Then we have kaning chromium. Chromium, once it reacts with another element, this will have a brick red color. Ano siya? Colorful ang solutions aning transition elements. So there are 4 types of elements. No? They are either diatomic elements, allotropes, liquids, and radioactive. Okay. So if you talk about diatomic, meaning duha ni siya ka atom in an each element. Na? So kanila gyud siya ang diatomic. The iodine, the bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. Na? All the elements are monoatomic. Kanira ang diatomic, and the rest of the elements are monoatomic. The second type of element is the allotropes, meaning they have same element at various form. No? They have different physical and chemical properties. No? Pareho sila allotropes, pero pareho sila. Pero nag-differ sila sa physical and chemical properties. Can you still remember our isotopes? Kana siya, di ba? For instance, oxygen has 2 allotropes. Tawag ni is 2 allotropes. That's O2 and O3. Even hydrogen has 3 allotropes. That's H, H2, and H3. For instance, carbon also has 2 allotropes. The first one is a graphite. The second one is the source of diamond. Okay, that's allotropes. Pareho sila, but they differ in its physical and chemical properties. The third type of elements are liquids. No? Bromine is a non-metal, but it is 10 minutes na lang. Bromine is a non-metal, but it is in a form of liquid. Mercury is a metal, pero this is the only metal nga in a form of liquid. Then the radioactive element, all elements over 82, sugod na ganing 82 ang atomic number, these are radioactive. Why? Because they have no stable isotopes. Okay. So the next thing is effective nuclear charge. What is effective nuclear charge? This is a characteristic wherein this will measure how electron is attracted to the nucleus, and at the same time how electron repel to the nucleus. Kana siya. So the nuclear charge of an electron fields depend on its attraction and its repulsion. So how it is being done? So electrons in lower energy level will shield, tabunan. Katong electron nga tuas lower ang energy level, iyang tabunan ang positive charge positive charge nga nucleus. And that's it. So how are we going to compute the effective nuclear charge? Effective nuclear charge has formula of ZF. Z then EF. Z if or if ni siya. This if is effective. This Z is the number of atomic number. Na? That is. So where Z is the atomic number, Z is the atomic number, then S is the screening constant. How are we going to compute the screening constant? Screening constant is N minus 1. Kaning N is the energy level, the main energy level minus 1. And that is effective nuclear charge. So let us compare krypton, chlorine, oxygen, which will have largest effective nuclear charge. For instance, chlorine, the atomic number of chlorine is 17 minus what is its what is its N? That is 11 minus 1, it's 10. So 17 minus 10 is 7. Then oxygen, the atomic number is 8. Then 2, nga naman, that's 2, then 8. So 2, 8, so it's 2. Ang N mo is 2. 8 minus 2, 6. So among these, ang pinakataas is the chlorine. Chlorine has a higher effective nuclear charge. Okay. So let us, before we start with the second, I will stop sharing muna.